Welcome to Spring LIB.
Okay, so first off, I want to point out that when you're doing ozonolysis, you're taking some alkene, reacting it with O3 and DMS. This is in the forward direction. They're being asked us to do this in the reverse direction. What you're basically doing is cutting an alkene in half and then gluing sort of an oxygen to either end of it so that you get something like this out. We get the left half of the molecule and we add an oxygen at the end of that double bond. And then we get the right hand of that molecule. We add an oxygen at the end of that double bond. And what they're asking us to do is to do this backwards. They're saying we have two ketones or aldehydes or carbonyls. Can you glue them together and figure out what they would have looked like before they were split in half by ozonolysis? And so the way you do that is say, okay, we'll get rid of these oxygens and then sort of glue the two halves together so that we get something that looks like this in a sort of cartoony fashion, right? And then we just kind of redraw that with a shortened bond so it's not so cartoony, like so. And that's how we can get from two carbonyls back to our original molecule. We eliminate the oxygens and glue the carbons back together, basically. So in our case, we've got this carbonyl. I say carbonyl because it can be either a ketone or an aldehyde. So that sort of covers both. And this one, okay. And so what I'm going to suggest we do is eliminate the oxygens and then glue one to the other, like so. So it basically means we have to flip this molecule over and like kind of cram it down on the top there. So what I'm going to do is redraw the right-hand molecule. I'm going to draw the double bond, but not have it go to oxygen because we've eliminated that. I need it to go to this carbon instead, which I see just has two methyl groups on it. And then I'll draw my hydrogen. Okay, so this is the alkene that when split up and you put oxygens on either side of it, gives you these two molecules that we started with. Right, so this is our final answer.